All right, Honors Algebra 2, welcome to your Section 6567 game plan video for the spring of 2019. Today, as always, brought to you by Chinatown here in Litchfield, Laura Bar, Lemon, and Yogi. All right, I'm going to turn the page, disregard that due date. That was from 2 years ago. Okay. Again, we've had a weird schedule since I was gone for the birth of Elsie May. So actually, 6.5 to 6.7 game plan is going to be due relatively soon, even though at the time of this video, we haven't even taken the Chapter 5 test. So we will be hitting it hard, and we will go at a pretty quick pace when I get back. All right, page one in this. Again, now we're going to be breaking down radicals that, when we take the square root of 12, it doesn't come out cleanly. So we got to break 12. 12 is 2 times 2 times 3. So 2 goes on the outside. I can already see, look at that, great start. I already see a typo. All right, so 2 gets the break out of radical jail. Now that imaginary 2, we ask ourselves, what's 5 divided by 2? It's 2 with 1 left over. That's why there's an x there. 2 goes into 6 3 times cleanly. No y's in there. And then that 3 has to stay on the inside. Okay? We'll probably do this whole page together in class. The cubed root of 8 is 2 with nothing left over. 3 goes into 4 1 time with 1 left over. 3 goes into 17 5 times with 2 left over. Make sure to put the little 3 on the outside. What's left over is not the square root, but the cubed root. Disregard that. The cubed root of 16 is 2 exactly. 2 goes into 22 5 times with 2 left over. 4 goes into 22. 4 goes into 12 3 times exactly. Now, that's what's left over, guys. X to the 2/4 is the same thing as x to the 1/2. So you can write it like that. Okay? Page 2. Same type of deal, you just break down 72. 72 is 3 times 3 times 2 times 2 times 2. So 3 times 2 gives you 6 on the outside. 2 remains on the inside. 2 goes into 9 4 times, 1 left over. 2 goes into 5 twice, 1 left over. All right, and there is 11 and 12. That's how you do that. Put the imaginary 2 on the outside. All right, breaks down like that. Now, again, pause this whenever you need to. Here's what we do here. 14, you're going to do 5 times 6. Let's just combine things first. 5 times 6 is 30. I can multiply with n. This would be x to the 10th. That would be y to the 7th. I'll break this down. That's an imaginary 2 on the outside. It goes into 10 5 times exactly. The imaginary 2 goes into 7 3 times with 1 left over. Okay, on this one, we multiply on the outside 3 times 4, 12. And then multiply on the inside. Imaginary 2 on the outside. 2 goes into 3 1 time with 1 left over. 2 goes into 9 4 times with 1 left over. All right. Page 2. So, some more practice. Multiply things that are on the outside together. Okay? Then multiply what's inside the square roots together. Now, the square root of 16 is 4. The square root of x to the 4th is x squared, so no more square root on that one. Okay, we got to break down what's the square root of 40. The square root of 40 is 2 root 10. When you break it down, the square root of 28 is 2 root 7. The square root of 200 is 10 root 2. Notice how I know that 10's not a prime number. We're supposed to stop when we get primes, but 10's a pair, and that's the whole goal, is to find a pair. You guys can't simplify because everything inside the square root is a different number, okay? Here we go. 21 is probably the hardest one I can give you. So you break down the square root of 12. The square root of 12 is 2 root 3, but that 2 is going to go on the outside. It's going to multiply with 9. What's 2 times 9? 18. That's why it's 18 root 3. Plus, break down the square root of 32. It is 4 root 2. So this 2 times 2, which is 4, multiplies with 5 to give you 20. That 2 stays on the inside. And lastly, square root of 72 is just 6 root 2. Gosh darn it. There's another boo-boo. So this is going to be plus 14 root 2. Okay, plus 14 root 2. Not 26, you're subtracting. All right, let's do a little distribution with roots. First, outer, inner, last. 4 times 3 root 2. You can do the 4 and the 3 to give you 12 root 2. 4 times 3 root 5, that is just 12 root 5. 2 root 5 times 3 root 2. So the 2 and the 3 go together to give you 6. Root 5 times root 2 give you root 10. Plus, now folks, as we talked about in class, 2 times 3 is 6. Root 5 times root 5 is going to be the square root of 25, which is just 5. Okay, the roots cancel. And it breaks down to give you that. Give conjugates on 26. X, X, Y, Y, plus, minus. So you just do the first part of the FOIL. 8 times 8 is 64. Root 5 times root 5 is just 5. Minus, because a negative times a positive is a negative. 6 times 6 is 36. Root 3 times root 3 is just 3. All right. Not allowed to have i's or roots in the denominator. No, no, no. So, got to multiply top and bottom by conjugate. Notice how the conjugate up top, when we had conjugates, we didn't have roots in our answer. So that's what we're going to do. The conjugate of the denominator would be root 5 plus root 3. Up top, we're going to do root 2 times root 5, root 10, plus root 2 times root 3, root 6. At the bottom, you're going to have root 5 times root 5, which is just 5, minus, because you have a negative times a positive, root 3 times root 3 is just 3. 5 minus 3 is 2. Folks, we can't divide everything by 2 because that is in the square root jail. All right, it's protected. Down below, this next one, again, we're going to multiply top and bottom by the conjugate of the denominator, so root 2 minus 3. Up top, it's just going to be 5 root 2 minus 15, 5 times 3. At the bottom, we're going to have root 2 times root 2, which is 2. 3 times a negative 3, which is a negative 9. 2 minus 9 is a negative 7. Normally, we don't want negatives in the denominator, but we've done enough work on that one. All right. Okay, this page is where it gets interesting. You know, there might be some quicker methods. I'm going to show you how to do it this way first, folks. As I said before, we don't want square roots in the denominator. So what we're going to do is we're going to multiply the top and the bottom there by that square root. Why are we going to do that? Because when we have one square root multiplied by itself, the square root goes bye-bye. Okay? So I'm going to multiply top and bottom by the denominator. Get rid of that square root. Okay? So that's good. I have no square root in the denominator. Check. Now I just got to simplify this. There's an imaginary 2. 2 goes into 7 3 times with 1 left over. Imaginary 2. 2 goes into 3 1 time with 1 left over. Now notice you have y over y to the third. Again, that y is protected. Can't do anything with it. But y over y to the third would cancel. That y would go bye-bye, leaving you with y squared in the denominator. All right? So that's another one of the hardest ones I can give you. Here's 34. So again, when I have the square root of, you know, some rational function, 3 over 2, I can just write it as the square root of 3 over the square root of 2. That is totally legal. Now I'm going to multiply top and bottom by that denominator, that square root there. So it's just going to give me 2y to the 5th. And when I multiply top and bottom by 2y to the 5th and the square root, 7 times 2 is 14. You have x to the third, y to the 5th. All right, so this is looking... Okay, sometimes this might be the answer, but we are going to have things that are going to come out. First off, the square root of 14 doesn't break down. It's just 2 and 7, no pair. That imaginary 2 goes into 3 one time with 1 left over. That imaginary 2 for the second root goes into 5 twice with 1 left over. Notice how you do have some y's that will cancel. Y to the third will remain down below. All right, so you're just going to have a few of those that we'll take our time with. Folks, we're not looking for pairs, we're looking for triplets there. All right, what number, you know, so we're circling any triples. All right, so break down 54. 54 is 2 times 3 times 3 times 3. So that 3 goes on the outside. The 2 is left over, and it's not the square root, but the third root. 3 goes into that 6 for x, the exponent, twice with nothing left over. 3 goes into 11 3 times with 2 left over. There it is. All right, let's go to the next page. 6 is pretty easy. So, folks, here's how you can do number 3 in the warm-up. That's just the square root of 30 divided by 6, which is the square root of 5. That doesn't break down. And 4 you guys learned in junior high. Okay, so write it in radical form. Okay, so the denominator of that exponent is the root you're taking. You're taking the third root of 11 to the first power. You're taking the third root of x squared. That's telling you you're taking x to the 2 over 7. You're taking x to the 1 over 2. When you multiply with the same base, you add the exponents. So let's make the exponents the same denominator. 3 over 2 is 6 over 4. That's x to the 9/4. Just subtract exponents. X to the 3/2. Very easy page. All right, just arithmetic, honestly. And page 7. Give you a few more answers there. Add the exponents. You already have the same denominator. Add the exponents. You have the same denominator. Call it 3 over 2. All right, add the exponents. Add the exponents. Get the same denominator, which is 8, the least common denominator. Just add them up. Power to a power, you multiply the powers. So 1 times 5 over 2 times 4. Very easy. Oh, these are fun. Number 19, square root of a square root, inception style here. You're going to do the square root of 81 first, which is 9. Then you're going to take the square root of 9, which is, piece of cake, 3. See this one? You're going to take the square root of 729, and I'll teach you, you're really taking the 6th root of 729 for your answer. The square root of 729 is 27. Then you're going to take the 3rd root of that, which is 3. All right, let's go to the next page, which is page 8. What number squared gives you 25? 5 and -5. Okay, now we're kind of going backwards here. So I'm telling you, the square root of some number is 7. Well, that's got to be 49, right? There's only one number that if you take the square root, you get 49. That is different than before. Before I said take some number and square it to get 25. Okay, that could be a negative or positive that you started with. But I'm telling you that if you are taking the square root of a number and you get 7, there is one answer there. So let's do the opposite operation. Before, when I had x squared to get the answer, I took the square root. Now if I have the square root of x, I'm going to square both sides. When you square a square root, that just drops down. You get x is 53. Pretty easy section. Subtract 6 from both sides. You have the square root of x minus 3 is 4. Square both sides, add 3, boom. And then on 8, on 6, just add 5. Take the square root, or not square root, square both sides, and subtract 13. You should get 12. All right, folks, moving on here. The next page is just hashtag game time. You're going to cube both sides, add 2. You're going to square both sides. Just be careful. When you square 2, you get 4. That drops down. Use distribution. Go from there. You're going to add 4, or add 3 to the other side to get 4. What's the reciprocal of 1/4? It's just 4, so you're going to raise everything to the 4th power. Go from there. All right, so on 16, add 4 to both sides. You're going to cube both sides. Subtract 8, square both sides. There you go. Page 10 is bonus honors algebra 2, but I did give you a little hint on 19. Yeah, when you square both sides, you're still going to be left, when you FOIL this, you're still going to be left with square roots. You need to move things over. Then you're going to have to square both sides, so you should get that answer. But that makes 18 not totally impossible. Oh, I can see little Elsie Mae crying down. I can hear her crying downstairs. So let me finish this last page. And it's just some review. There's the answer on the very last page here to number 2. Again, look at that work. There's 5. There's 7. Conjugates, so if you see conjugates, just first, outer, inner, last. When you have roots in the denominator, you have to multiply by conjugates. Okay. When you multiply with the same base, add the exponents, divide with the same base, subtract the exponents, and that is an 8, not a 6. Square both sides, get 13. All right, folks, this is your 6-5 to 6-7 game plan video. This is Yak Math Video signing out.